This is problem number 1 from your geometry section. You'll have 10 geometry problems, or will have already had probably. All right, so this is a really complicated picture of a circle. It says use the following information about circle S. Now here's one important thing. They called this circle circle S, and that's very critical. That means this is the center. 100%. You know it. You don't have to wonder, is it actually the center? The name of the circle will be the center. Okay? They won't call it that if that's not the center. So, TW and VX are diameters. TW, okay, that's going right through the center, and VX are diameters. You don't know anything about them necessarily, but since you know the S is the center, you know that S splits these, and all of these have the same length, okay, because they're diameters, and so SV is a radius, ST is a radius, SX is a radius, and SW is a radius. It tells you that WX and TX are chords. Chords just means it slices through the circle somewhere, does not have to go through the center. Although it could, these clearly do not. So this is a chord, and this is a chord. And if you knew the definition of chord, you probably didn't even need to be told that, but they're just being sweet and letting you know those are chords. Okay? It says that US is a radius of circle S. Another thing that you probably could have figured out, because if S is the center and U is on the circle, then obviously it is another radius right there. It also tells you that TW is perpendicular to VX. So you know that this is 90 degrees, and this is 90 degrees, and this is 90 degrees, and you know that this entire area, and I'm going to color it in so that you can see it, there and there combined is also 90 degrees. Now, I haven't looked to see what questions they might ask, but I do see that this is 51 degrees. UST is 51 degrees, which means this one would have to be whatever is left for that to be 90 degrees. So if you do 90 minus 51, that would be 39 degrees. So I do know that's 39. I don't think that's the question that they asked, but, you know, it's worth noting, 39 degrees. So here's the question. What do T, U, V, W, and X? So let's just go through and find all of those. T is here. U, V, W, and X have in common, well, they're endpoints of radii. I would say the endpoints of diameter, but U does not have that in common. So let's see. Are they all the same length? Well, points don't have length. Those are points, and they don't have length. So we rule out A. They're the same distance from point S. Yeah, if they're on the circle, they're the same distance from point S. So that's right. They are all points on circle S. Oh, at this point, I think, wait a minute, what? All of the above. I have two that I definitely know are true. And then it dawned on me, hold on, I might have been too quick to rule out A. See, because what did I say about them? I said they're points. They don't have length, right? Well, what's something's length if it has no length? I guess it would be 0. So technically, they both have the same 0 length because there is no length to a point. So yeah, we're going to give that one a pass too. So actually, it is all of the above. So the answer is D to this question. All right, so relative to circles, let's move to your redemption problem. And let's look at this one. It says, which segments could be contained in distinct parallel lines? 2 radii, 2 chords, 2 diameters, a radius, and a diameter. Big thing that you need to know here, distinct means not the same, different. Okay, and the reason I say that is because in parallel lines, if I have this line, and I'll call that line L, and then I have this line, okay, and I call that line M, those are not distinct. It's one on top of the other, and so you really wouldn't include that as distinct. Distinct means literally not on top of one another. They are parallel, same slope. We're going to pretend that you see that these are parallel. okay? And they are clearly different lines, okay? So answer that question, check it out with your teacher, and good luck.